From our background of Hooke's law, we have said we are going to look at Hooke's law in 2 ways. We are going to look at the statics and the dynamics. The statics is under the experiment 6. So experiment 7 is Hooke's law dynamics. What it means is that now we are going to be loading this spring with the provided masses, and we are going to be setting it into oscillation. Then the apparatus we need for this experiment is we need a Newton stand, spiral spring, masses with mass hanger, and a stopwatch. So those are the things that we need for this particular experiment. Now, before going to that, the law of Hooke's law that we stated earlier corresponds to this one too, which is represented by equation 1. The extension is proportional to the force that's causing the extension of the spring, which implies that the extension is equal to mg all over k, where k is the spring constant. That's our equation 1. And also, since we are going to set this the spiral spring, we are now going to set it into oscillation. From equation 2, we have the period of oscillation for setting the spiral spring into oscillation. Now, the table of observation is going to look like this. Now, we are starting with 20 gram mass. All you need to do is load the spring with 20 gram. Then you set it into oscillation while holding your stopwatch. You count down from 3, 2, 1, and you start your oscillation and you start counting. So when you get to 20, you stop it and take your reading. Whatever value you get, you're going to record it under this T1. I hope this is clear now. So there are 2 ways to do this thing. Either you do this twice, or you finish for T1, you go for 20 grams, you take the time for 20 oscillation, you record it. For 40, you do the same for it, 60 and 80 and 100. Or you repeat for 20 twice, so that when you record one here, you repeat it again, you put it here. It's all the same thing. It's either you go through, you fill the time for this, and you take this again. So the next one is for you to take the mean time. That's T1 plus T2 divided by 2. That will be your mean time, which is also in seconds. Now, we have stated here that the number of oscillations we are going to allow this spring to go is just 20. So that means to get the period from equation 2, our period is going to be the total, that's the mean time divided by the number of oscillations. So when you do that, whatever mean you get here, if you divide by oscillation, we're going to have your period that corresponds to each of these masses. Then the last column corresponds to the column for the square of the period, which is t squared, which is also second square. So what you need to do is whatever value you get under this, you just multiply it by itself or raise it power 2, and you have your value. So that is how you are going to get the value for this experiment. It should be noted that the major problem that we are going to doing this experiment is for you to taking the time and taking the corresponding, setting the spiral spring into oscillation and taking the time at the same time. So if this experiment is going to be performed in group, somebody should be holding the wristwatch and the stopwatch, while the other person should be in charge of setting it into oscillation. And the person holding the stopwatch should count down from 3 to 0. It is stated in the manual. So when you are done with this, then you are done with the experiment. Now, we now go to the question under the experiment. It says that you should explain in your conclusion to this experiment how this experiment has allowed you to verify Hooke's law. Okay? Then the second one, you will be able to do this when you plot the graph. Then the second question says plot the graph of mass against t squared and determine the slope and the intercept on m axis. The next question says define the type of motion performed by a vibrating spiral spring. And the last one, state 2 precautions taken to obtain accurate reading. So that is just about this second experiment. Thank you.